Welcome to Math with Truth. We're starting a new series called Indices, and we welcome you to stick with us through it. This is the first episode, and so we start from the very beginning, where we're going to look at what indices is, the different parts of indices, and what they mean, and why do we need indices? Why do we write numbers in the form that we call indices? Then we look at the product law of indices. There are several laws of indices. The laws help us to calculate indices, to simplify it, and to work with indices. And we're going to look at those laws. The approach that we take in our tutorials is to help you derive the laws, and so then you know where they're coming from. That way, it sticks with you for a long time. And then we solve questions to ground the skill that you um, build from this tutorial. So we start with the baby steps in all our episodes. So yeah, happy babies. Let's go. Numbers written in this form are called indices. So what are they? What does that mean? So when you have a number like 2 exponent 2, that means 2 multiplying itself 2 times. Okay, so we have 2 times 2. Or when you have 3 exponent 2, that means 3 multiplying itself 2 times. So 3 times 3. If you have 4 exponent 3, that is 4 multiplying itself 3 times, we have 4 times 4 times 4. Oh, 4 times 4 times 4. Now, the base, which is the number multiplying itself, is called the base, right? That is the big number written here. And then this small one, that superscript, is called the index or the exponent or the power. And that indicates the number of times that the base should multiply itself. So if you have 10 exponent 5, the base is 10. That means 10 is going to be multiplying itself. And 5 determines how many times 10 should multiply itself by. And so you have 10 times 10 times 10 times 10 times 10. And that is what it means. That is indices. Here, this is the base, and the superscript written, that's number written, like a superscript, is the index or power or exponent. And yep, that is their formal definitions or explanations to them, what they are. But then just know that the base is the number multiplying itself, and the exponent indicates the number of times that the base should multiply itself by. So this number is 10 multiplying itself 24 times. That's quite huge, right? Well, that is the very, very essence of indices. So indices helps us to write very huge numbers in a very simple way. For instance, if we have a number like 0, what's that? Well, 10 million, for instance. Now, imagine writing 10 million in a calculation over and over again, about 10 steps. Uh, that's going to take a whole lot of space. It's going to take time. You're prone to make mistakes. You miss a zero or you add a zero, and there could be a lot of consequences to it to throw your solution off totally. So One way we deal with that is to write it in this form, indices. So 10 million can be written as 1 by 10 exponent the number 1, 2, 3, 4, 5, 6, 7 zeros. So exponent 7. See, this is very tidy. It's easier to write. It takes less space, less time to write it, and you can be more consistent with this than writing this whole 10 million in the normal form, okay, in the ordinary form, we call it. So writing this way is better. Another thing is when the number is very small. So if you have like 0.0000000001 and you have to write this over and over again in your calculations, well, it could be prone to a lot of mistakes. So one way of going around that is to write this number in the indices form. And so how many zeros do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So you have 10 exponent negative 9. And this is the same as this number here. And so that gives you a very clean way of writing. It's easier that way. Now, apart from making your work neat and sort of shielding you from errors, writing numbers in the form of indices also helps us to calculate or visualize growth. Things that have to do with growth, it's easier expressing them in indices form. For instance, compound interest. You see how money grows over time when invested, or how populations grow over time. There are several applications of indices in engineering, for instance, especially when dealing with growth. You see, something that is increasing exponentially. It's better expressing them in this form. So that is indices, and that's some of the uses of indices, why we write numbers that way. But when we write numbers that way, we also need some rules, some laws to deal with them, to know how to simplify them and work with them comfortably. And that is what we'll be doing for the rest of this series. The first law that we will look at is the product law. But let's get to it. We will go through some steps and then you derive that law. Okay, so let's get to work. The first question that we have here is we have 2 exponent 2 times 2 exponent 3. Well, if you have 2 exponent 2, we have a special name for it, which is 2 squared. And exponent 3, we call it cube. And so we have 2 squared times 2 cube. What will that be? Now, here we have 2 times 2, which is 2 squared, okay, times, then the 2 cube is 2 times 2 times 2. This is equal to 1, 2, 3, 4, 5. 2 multiplying itself 5 times, so that is 2 exponent 5. Then we have the second one. So we have 3 multiplying itself 3 times, so we have 3 times 3 times 3. Times 3 multiplying itself 4 times. We have 3 times 3 times 3 times 3. What would that be? 1, 2, 3, 4, 5, 6, 7. 3 multiplying itself 7 times. So 3 exponent 7. The next one is 5 exponent 4, meaning 5 times 5 times 5 times 5 times 5 exponent 6, which is 5 times 5 times 5 times 5 times 5 times 5 is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5 exponent 10. Okay, that's cool. Uh-oh. Now, if we even have the time to write this, the space to write 5 times itself, 100 times 5 times itself, 231 times, and then count everything, it's going to take us a whole lot of time and it's going to occupy a whole lot of space. In exam conditions, the exam will be over by then. So then we need to come up with a law that we can use to resolve this quickly without writing them out this way, you see. So there is one thing in math, generally in life, observations, patterns. And so let's look at the first 3 that we did and see if we can derive a pattern that we can use to resolve this one, the 4th one. So here, let's look at this. Look at 2 and 3, and then we have 5 here. Well, think about it. What's the relation? 2 plus 3 is 5, right? Okay, so we can say 2 exponent 2 plus 3, which gives us 2 exponent 5. Well, that works. Let's use that logic for the second one. We have 3, well, here, 3 and 4, and that gives us 7. Still, plus works. And that gives us 3 exponent 7. And then we have 5 exponent 4, 5 exponent 6, 4 and 6, and that gives us 10. Okay, it works again. 4 plus 6, and that gives us 5 exponent 10. Then we can use the same logic with this large one, number 4. And so we have 5 exponent 100 plus 231. And that will be equal to 5 exponent 331. Okay, and that is correct. Now, generally, what will be the rule if you have a exponent n times a exponent m? What do you think the rule will be in general terms? That will be, look at the base, the bases are always equal, all right? So if the bases are equal, then you have a exponent, you add the exponents, n plus m, and that is the product law of indices. So the product law of indices states that when you have one indices multiplying the other and the bases are the same, then you just add the exponents. Okay, so you have a exponent n times a exponent m is equal to a exponent n plus m, and that is the product law of indices. Now, knowing that, let's then take some questions. One, we have this is x exponent 4 plus 12, which is x exponent 16. The next problem is a exponent negative 3 times a exponent 7. Now, negative exponents have a little bit more meaning to them than we are concerned with for now. Okay, we will deal with that in later episodes. So for now, just don't bother about the deeper meaning of negative exponents. Okay, just treat them like any exponent. So you have a exponent negative 3 times a exponent 7. And that will be a exponent -3 plus 7. And that is a exponent 4. Then you have k exponent -4 times k exponent -6. So here we have k exponent -4 plus -6, which is equal to k exponent -4 minus 6, which is -10. Then we have y exponent half times y exponent 3/2. Now, when you have point, this is also representation of multiplication, okay? And so we have this, and like the negative exponents, don't bother about the fractional exponents. They also have a bit more meaning to them than what we are concerned with now. We'll look at that again in later videos. So here, just treat them like any exponents. So here we have y exponents half plus 3/2. And this is equal to y exponent. Since they have the same denominator, you only work with the numerators. We have 1 plus 3/2, and this is equal to y exponent 4/2, which is equal to y exponent 2. And then here, well, when you have numbers this way, or indices represented this way, well, it just means 5 m exponent 5 times n exponent 3 times n times m exponent 2. So that is working with the commutative property of multiplication. We can actually represent this as m exponent 5, m exponent 2, n exponent 3, n, and this will be m exponent 5 plus 2, n exponent 3 plus 1, which then gives us m exponent 7, n exponent 4. This plays with the distributive property of multiplication, right? So if you have, for instance, a into bracket b plus c, what happens is that you distribute, you have a times b and a times c, and you maintain the operation in the bracket, right? So then you have a times b plus a times c. So you have a times b plus a times c. And it's the same thing we're going to use here. Okay, let me wipe this. So we have 7x exponent -2 times x exponent 12 plus 7 times 2, that's 14, x exponent -2 times x exponent 3. Now here we can then simplify. You see we have 7 and we have x. Here we have the product law applying. We have -2 plus 12, and we have plus. Here we have 14x. Then here we have the product law. We have -2 plus 3. And this will give us 7x exponent 10 plus this is 14x exponent 1. And if you have exponent 1, it's the same as just the number. So you really don't write exponent 1. We will come to that. So it's just the number multiplying itself 1. So if you have x exponent 1 is the same as x. All right. So here, this is we can leave the answer this way since here we are interested in indices, or you can further simplify it to be 7. That is if you're factorizing, which I hope you have done, or we will have a video in the future on factorization, which you can watch. And here we have x exponent 9 plus 2. So you can leave your answer this way. All right, so let's do this one. Again, you can pause the video and solve the question before you watch the solution. And if this is helpful for you, don't forget to like the video, subscribe to the channel, and share it with friends. Okay. All right. So here we have x. Then you apply the product law that you have developed. You have 3a minus 2 plus 5 minus 7a. And this will be x exponent. We have 3a minus 7a. That's you group in like terms. And then you have negative 2 plus 5. And so then you can resolve this one. We have here 3a minus 7a will give you negative 4a. Minus 2 plus 5 will give you plus 3. Well, you can leave it this way. You can arrange it to look a little bit more elegant. You have 3 minus 4a. So that is the answer. Now let's do this. So this again is just a chain of multiplications that's put together. There are several ways that multiplications can be represented. So you can have a times b, which we know. We have a dot b, a into brackets b, and just ab. All of this just mean a times b. Okay, so you can have a exponent negative 3, a exponent 7, a exponent negative 2, b exponent negative 4, b exponent negative 9, b exponent 5. Okay, and then you have here the law applies. So you have a exponent negative 3 plus 7 minus 2. Okay, and then times b exponent negative 4 minus 9 plus 5. So just negative 3 plus 7 plus minus 2, which is the same as just writing 7 minus 2. Or here, negative 4 plus minus 9, which is just the same as writing negative 4 minus 9. Okay, and so you simplify this one to be a exponent here is going to be 4 minus 2, and that is going to give you a squared. Let me write my a properly. A squared times b. This is negative 4 minus 9 will give you negative 13, and plus 5. Negative 13 plus 5 is negative 8. And so this is the simplification of that indices. This long thing, we can simplify it to this. Now let's work with this. You can pause the video and simplify this one. Okay, let's do it. So we have x exponent 3 over 2 times y exponent negative 4 times x exponent negative 5 over 2 times y exponent 7. So this we can just bring those with the common basis together again. So we have x exponent 3 over 2, then we have x exponent minus 5 over 2, then we have y exponent negative 4 and y exponent 7. So then we have x applying the product law, we have 3 over 2 minus 5 over 2. Then we have y exponent negative 4 plus 7. And then we simplify. Here, since we have a negative, let me just write this. Negative, this is 3 minus 5 all over 2. Because the denominators are equal, we just have to subtract the numerators. And then we have y exponent negative 4 plus 7. That will give you positive 3. And so here we have x exponent, here will be negative 2 over 2, which then gives you negative 1. And then we have y exponent 3. Now, note that when you have x exponent 1, this is equal to x. But x exponent negative 1 is not x. We will look at that later. Okay? So just know that one, that if you have x exponent 1, that is equal to x. That's okay. But x exponent negative 1 is not x. We will look at what that is in later videos. Okay? You see that that will be 1 over x. Why? Don't worry. We will look at that later. Okay, let's solve this one. If you have two indices, so a exponent n, and that is equal to a exponent, say, b, since the bases are the same, then the exponents should also be the same. So you have, say, 2 exponent 3 is equal to 2 exponent x. There is no other value for x than 3. Okay, since the bases are the same, the exponents should be the same as well. So then x should be 3, so that you have 2 exponent x being equal to 2 exponent 3. Okay, so then we're going to apply the same principle with what we have, the question that we have on the board here. So then let's solve this. Let's simplify this one. We have 2 times 3. Then we have x exponent a, x exponent negative 3, x exponent 4, x exponent 3 is equal to 6x. There we have 10 minus a. 10 plus minus a, which is 10 minus a, yeah? And we simplify this one to be 6. And then here we have x. This is a minus 3 plus 4 plus 3 is equal to 6x, here 10 minus a. Now, this negative 3 and plus 3 will be 0, so that is out. And then we have 6x, here will be a plus 4 is equal to 6x, 10 minus a. Now, here we can divide both sides by 6, so this 6 goes away, leaving us with the pure indices to work with. So here we have x exponent a plus 4 is equal to x exponent 10 minus a. Okay, so then since the bases are the same, the exponents should be the same as well, should be equal. So we have a plus 4 is equal to 10 minus a. And this gives us a linear equation to solve. And here we have, let's add a to both sides. So we have this plus a, and here plus a. So this will be a plus a, which gives you 2a plus 4 is equal to 10. This will go to 0. Yeah, negative a plus a will go to 0. And then we subtract 4 from both sides. We have 2a is equal to 10 minus 4, which is 2a is equal to 6. We divide both sides by 2, and a is equal to 3. So let's see if this is correct. We can actually use this expression here. So we have x exponent a, the value of a is 3, plus 4 is equal to x exponent 10 minus 3. And then this gives us x exponent 7, that is 3 plus 4, is equal to x exponent 10 minus 3, which is 7. So you see, x exponent 7 is equal to x exponent 7. Now, that is how you solve this type of questions. We have these examples for you to work with. These ones, we call them the skill builder. Um, so when you practice with this, it helps you ground your skill, to develop it, to make it more concrete, to make it more lasting, to ingrain it. And so that is what we achieve with this skill builder. So it helps you, the questions are selected in a way that helps you deal with the different ways of working with the product law of indices that you have derived. So work this, and then we have another video in which we go through these problems. So first, pause the video, solve these ones, and then you can watch that video that in which we go through these problems. Okay, all right. So then, yeah, let's summarize. We looked at indices, so that those are numbers written in this form where we have the base and then we have the index. And the plural of index is indices, anyways. So we have the index or the power or the exponent. And then those are the parts of indices. And we looked at why we need indices, as in making calculations simpler, simplifying things, making them neater. Um, and then we also use that to represent growth. So anything that represents growth, you can write them in the form of indices, like compound interest or population growth, or a whole lot of things in science and engineering. They use these indices or exponents. And then we looked at the law of indices, which you derived, and then you solved a whole lot of questions with it. Then you have the skill builder to work with. Probably you have maybe gone through it already, and that is fantastic. And so, like the video, subscribe to the channel, and hit the notification bell, so when we upload future videos, you will have them. And don't forget to share with friends as well, so they can follow the channel. What we want to achieve is free education, quality education, especially in math for all. And so join the community of people trying to learn math, and then we grow together. All right, so see you in the next one. Bye.